In this episode of Remote Trigonometry, we will be discussing the fabulously ubiquitous unit circle. It is called the unit circle because it is a circle centered at the origin with radius equal to 1 unit. Unit being anything you want to measure. So 1 centimeter, 1 inch, 1 foot, or any made up unit you would like. But your unit circle has a radius of 1 of those units. A radian is an angle measurement such that the arc of the circle is the same as the radius of the circle. And it doesn't matter how big your circle is, if you measure an angle so that this arc is the same as the radius of the circle, it will be the same angle in any circle. And Archimedes proved that 2 times pi of these angles make up a complete circle. So 360 degrees is equivalent to 2 times pi, or approximately 6.28 radians. So we will start there, and we have some famous angles that we are going to focus on. In a right triangle, if one angle is 30, the other angle is 60, and if one angle is 45, the other angle is 45. So 30, 60, 90 degree triangles and 45, 45, 90 degree triangles are very helpful, kind of famous triangles. So we'll be focusing on 30, 45, 60 degree angles as we go around the circle. Now notice a circle is symmetric in every direction. So quadrant 1 is symmetric to quadrant 2, is symmetric to quadrant 3, is symmetric to quadrant 4. So recognizing that is going to be extremely helpful in terms of recognizing all the patterns that emerge. So let's start again with pointing out that a full circle, a full turn of 360 degrees is 2 pi radians. Again, a radian is an angle such that the arc is the same as the radius of the circle. So a half of a circle, 180 degrees, will not be 2 pi, it'll be 1 pi radian, because it's half of 2 pi. And then half of 180 is 90, so half of a half circle, a quarter circle, is 90 degrees, and so its radian measurement is half of pi, or pi over 2. If I went 1/4 of a circle, 2/4 of a circle, 3/4 of a circle, it will be 1 pi over 2, 2 pi over 2, 3 pi over 2. So 270 is 3 times pi over 2 radians. So notice I've connected 90, 180, 270, and 0, by the way, is always 0. So 0 degrees is also 0 radians. And then 360, a full circle, is 2 pi radians. Connecting the quarters of a circle is what you want to do. So again, half of 2 pi is 1 pi, half of pi is half of pi, pi over 2, and then 270 degrees is 3/4 of a circle, so it will be 3 times pi over 2. We're going to do that same thing with these other angles. So 30 degrees is 1/6 of 180 degrees, and 180 degrees was pi, so 30 degrees is 1/6 of pi. So 30 degrees is pi over 6. So notice that 30 degrees is 30 degrees away from the x-axis. 150 degrees is also 30 degrees away from the x-axis. It's just from the negative x-axis. So 180 was pi, 6 pi over 6 would be pi. So 150 degrees must be 5 pi over 6. 1 less pi over 6 than pi. Another way to think about it is that 150 is 5 times 30. So 150 degrees is 5 times pi over 6 because pi over 6 was 30. So 150 is 5 times pi over 6. 210 is 30 degrees away from the x-axis. It's 130 degrees past 180. So it's 130 degrees past 6 pi over 6. So it'll be 7 pi over 6. So 1 pi over 6 past 6 would be 7 pi over 6. Also, 210 is 7 times 30. So 210 degrees is 7 times pi over 6. So 7 times pi over 6 is how much radians 210 degrees equals. Now 330 degrees is 30 degrees away from a full circle. A full circle again is 2 pi. And so 360 is the same as 12 pi over 6. 330 is 1 pi over 6 less than that, 130 degrees less than a full circle. Also, 330 is 11 times 30. So 11 times pi over 6 is how much radians 330 degrees is. So notice 30, 150, 210, 330, they're all multiples of pi over 6 because they're all multiples of 30. Now let's move on to 45 degrees. So notice 45 degrees is 45 degrees away from the x-axis. So is 135 degrees. This angle here is 45 degrees. It's just from the negative x-axis. 225 is also 45 degrees past the x-axis, but the negative x-axis. And 315 is 45 degrees shy of a full circle or shy of the x-axis. 45 is half of 90. So what's half of a half? Half of a half is a fourth. So 45 degrees is pi over 4. So 45 degrees is 1 pi over 4, 2 pi over 4, 3 pi over 4. 3 times 45 is 135. So this is 3 times pi over 4. 45 was 1 times pi over 4. Then 225, it's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 would be pi, 5 pi over 4. And 5 times 45 is 225. Then 1 pi over 4 is 45, 2 pi over 4 is pi over 2 or 90, 3 pi over 4 is 135, 4 pi over 4 is 5, is pi or 180, 5 pi over 4 is 225, 6 pi over 4 is 3 pi over 2 or 270, 315 is 7 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And 7 times 45 is 315. Alright, so that gets us around the circle in pi over 4s. So now let's talk about 60 degrees. Notice 60 degrees is the complementary angle inside of a 30, 60, 90 degree triangle with the 30 degrees. So 60 is 1/3 of 180. So 60 is 1/3 of pi. So 60 is 1/3 of pi because 60 is 1/3 of 180. So this is 1 pi over 3. 120 is 2 times 60. So 120 is 2 times pi over 3. Then 180 would be 3 pi over 3. Again, 3 pi over 3. The 3's cancel, giving me pi. So 1 pi over 3, 2 pi over 3, 3 pi over 3. And then guess what? The next one is 4 pi over 3. 460 degrees is around the circle. So 240 is 4 pi over 3. And then 5 pi over 3 is 300. Notice 5 times 60 is 300. 5 times 6 is 30, so 5 times 60 is 300. So 300 degrees is 5 pi over 3. And then that gets us around the circle. One more 60 degrees puts us at 360, which is 6 pi over 3. And 6 pi over 3 would be the same as 2 pi. So there we go. That's the unit circle in terms of converting back and forth between degrees and radians. I would recommend that you think about this in terms of the patterns and not try to just memorize all these numbers. I mean, I do not have them memorized. I know them so well that I could easily spit them out, but I understand how they're all multiples of each other. I know that 150 is a multiple of 30, and 240 is a multiple of 60, and 315 is a multiple of 45. That's how you want to focus on it. Now, in terms of the x and y coordinates at these various angles, we want to point out some things we should know about 30, 60, 90 degree triangles and 45, 45, 90 degree triangles. If you have a 30, 60, 90 degree triangle, the side that is opposite 30 is always half of the hypotenuse. And so if my hypotenuse is 1, then the side opposite 30 degrees would be 1/2. So at 30 degrees, the the y coordinate will be 1/2, because the y coordinate is the side opposite the 30 degrees. Now up at 60 degrees, we have the reverse. X is now going to be the shorter side because this angle is 60, leaving this angle to be 30. And so at 30 degrees, the y is 1/2. At 60 degrees, the x is 1/2. So at 30 degrees, the x is not 1/2, the y is 1/2. And at 60 degrees, the x is 1/2. Now, in terms of getting the other coordinate, you have a right triangle. And the hypotenuse of the right triangle is 1, because the hypotenuse is the radius of the circle. Okay? So the x coordinate is the one side, and the y coordinate is the other side of the right triangle. So x squared plus y squared equals 1 squared. I'm just doing the Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus y squared equals 1 squared. If you then work through the algebra and you know that the opposite side of 30 is half of the hypotenuse, we know y is 1/2. 1/2 squared is 1/4. And so x squared plus 1/4 would be 1. Solving for x squared, I subtract 1/4. 1 minus 1/4 is 3/4. X then is the square root of that, and so that gives us the square root of 3/2. So at 30 degrees, the x coordinate is the square root of 3/2. At 60 degrees, it will be the reverse. 60 degrees is going to have y as that longer side. and x is going to be the shorter side. So the y coordinate at 60 degrees is the square root of 3 over 2. Now, for all of the angles that matched up with 30 and all of the angles that matched up with 60, the x and y coordinates are going to be the same numbers. They'll just be negative or positive depending on the quadrant. So over here in quadrant 2, x is negative. I'm on the negative side of the x-axis, but y is positive. I'm on the positive side of the y-axis. So at 120 degrees, x is negative 1/2, but y is still positive square root of 3 over 2. At 240, okay, down here at 240, x and y are both negative. And so x will be negative 1/2 and y will be negative square root of 3 over 2. At 300, x is back to being positive. I'm on the positive side of the x-axis. But y is negative. I'm below the x-axis, so y is negative. So x is positive 1/2, but y is negative square root of 3 over 2. Then for 30 degrees, if I go over here to quadrant 2, at 150, x is negative, but y is positive. So x will be negative square root of 3 over 2. Y will still be positive 1/2. At 210, I'm in quadrant 3, and x and y are both negative. So x is negative square root of 3 over 2. Y is negative 1/2. At 330 degrees, or 11 pi over 6, x is back to being positive. I'm in quadrant 4. I'm on the positive side of the x-axis. But y is negative. I'm below the x-axis. And so at 330, x is positive square root of 3 over 2. Y is negative 1/2. Now, for 45, we also want to recognize that you have a 45, 45, 90 degree triangle. Pythagorean theorem still applies. So this side will be the x and this side will be the y. And so x squared plus y squared is still going to equal the hypotenuse squared, because Pythagorean theorem always holds true for right triangles. But if you're talking about a 45, 45, 90 degree triangle, because these two angles are both 45, these two sides are both the same. So I can replace x with y, or I could replace y with x. It doesn't matter because they're both the same. So x squared plus y squared equals 1 squared, but 1 squared is 1. I get x squared plus x squared, because x and y have to be the same if it's 45, 45, 90. So x squared plus x squared is 2x squared. Solving for x squared, I divide by 2, and then I take the square root to get x. So at 45 degrees, x and y are the same coordinates, and it's equal to the square root of 1/2. Now, you can write the square root of 1/2. That's a perfectly good number. The square root of 1 is 1, so you could also write it as 1 over the square root of 2. If you like to rationalize your denominators and you multiply the top and bottom both by the square root of 2, thus keeping the fraction equivalent but turning it into this rationalized form, then 1 times the square root of 2 is square root of 2, and the square root of 2 times itself will give you 2. So these three expressions are all the same number. And honestly, in terms of my opinion, you could use any one of them because they're all the same number. So at 45 degrees, x and y are both the square root of 1/2, or 1 over the square root of 2. At 135, though, x is negative because I'm in quadrant 2. Y is still positive. At 225, x and y are both negative. And at 315, x is back to being positive in quadrant 4, and y is negative. Then at 0, now 0 and 360 are coterminal. It means that they land you at the same point. They're not the same angle. If a snowboarder did a 0-degree angle, it's not going to be a very impressive trick compared to if he did a 360. If he turned all the way around, that's more of a trick than if he didn't turn around at all. But they both land you at the same point. And remember, the radius of the unit circle is 1. So that coordinate would be 1 for x and 0 for y. So the x and y at 0 degrees is the same as the x and y at 360, and it's 1 for x, 0 for y. Now, at 90 degrees, I'm on the y-axis, and x is now 0, y is now 1. If I keep going and I rotate a half circle, and I'm at 180 or pi, x is now negative. So x is negative 1, but y is 0. If I rotate another quarter circle down to 270, y is negative 1, but x is 0. I'm on the y-axis. So x is 0, y is negative 1. And then that leaves us back to a full circle. So there you go. There's the full picture of the unit circle. It's how to convert back and forth between degrees and radians for our special angles. It gives you the x and y coordinate at all of these special angles. It gives you a right triangle proof of where the 1/2 and the square root of 3/2 come from, and where the 1 over square root of 2 comes from. And it also, points out the algebra. So hang on to this video and hang on to this knowledge, because we reuse all of this stuff over and over and over again in trigonometry.